Okay, we are back here with the next unit on functions, and it kind of continues with the last unit. We're going to see a lot of the same stuff with the y-axis, slope. So to get started, we're going to identify what a function actually is. So I drew this over here to the right because if you remember in elementary school, you might have had those function machines where they had a rule. So here would be the rule, y equals x plus 5. You probably just had like plus 5 when you're in elementary. So basically, whatever x is, so if x is 0, then you do this rule and you add 5, and y would be 5. And you don't have to write this down. I'm just kind of pulling your background memory up here. Okay, and I can't get that to write already. It's not a good sign. Okay, and then if x was, let's say, 10, then if you apply this rule, we add 5. So then y would be 15. And this was called that input-output machine or a function machine. So when we're identifying a function is a rule that assigns each input or x value. So each input, and you might want to put x here. So every x value, exactly and only one output. And you might want to put, the y value here. Okay, so if you think about that, like on this one, if x is 0 with this rule, with this function, the only possible answer is 5. If x is 10, the only possible answer is 15. So this equation would be considered a function. And later on, we're going to see ones that wouldn't be. Okay, so functions occur when every x value is associated or paired with exactly one and only one y value. So make sure that you know it's exactly one and only one. You might want to make a note of that and put only. Okay, so tables and ordered pairs. So to test whether or not a table, which is like this, or a set of ordered pairs represents a function, you just simply look to see if each x value, I'm kind of repeating myself, each input or x value has exactly one output or y value, which is basically what I was just saying over here. Then so that's for a table, or if like you have a set of ordered pairs, which we're going to practice down here. If you have a graph, if a graph represents a function, it should be able to pass what's called a vertical line, vertical line test. Oh my golly. Sorry, Danny. Cannot get that there. Vertical line test. That A is not supposed to be there. Okay. This means that any vertical line, which is an up and down line, that is drawn on the graph should intersect the graph at exactly 1 point and only 1 point. And again, I'll demonstrate that. Okay, so we're going to determine whether or not these are functions. And then we're going to explain our thinking, because otherwise it could be a guessing game. So on this table, you look at the x values, and -2 is only paired with 7. -1 is only paired with 1. Each x value only has one and only one of another number. So yes, this would be a function. The reasoning would be each input has only one output. Okay, now if we look at this set of ordered pairs, if you look at the x values, -2 is paired with 1, but over here it's also paired with 8. So this would not be a function. And for the reasoning, you could actually just circle, if you want to, circle the -2 or just put -2 repeats. Okay, or you could say, yeah, -2 has two different outputs. So this would not be a function, because if we'd go up here, it wouldn't pass that function test of one output for every input. Okay, now these are the graphs that we're talking about for a vertical line test. So on these graphs, you draw a vertical line, or you can just, eyeball it. And basically when you draw a vertical line, it should only touch it in one spot, and then it passes it. So like right here, it would only touch it right there, so it passes it. And you can draw a vertical line anywhere on there, and as long as it only touches it once, like right here, then it passes the test. So this would be a function. Okay, let's look at this one. So you can tell right away, if you draw a vertical line right here, it's going to touch it once, twice, and 3 times. So this is not a function. Okay, and on this one, should be pretty obvious. If you draw a vertical line, it's only going to touch it in one spot. Okay, if you draw it right here, it's only going to touch it here. So that does pass the vertical line test. Okay, and then let's flip it over on the back, and we're going to touch on equations. These are a little bit more difficult. So an equation represents a function if every input will only result in one output. Whoops. So you have to test it, you can sometimes substitute various input values to see if it represents a function. So we're going to test a few right here. We have y equals x squared. So why don't you try to think of some numbers that you could have put in here. So I'm going to draw a little t-chart. And if I have x and y, if I say that x is 5, if I follow this rule here, my golly. If I follow this rule, and I put 5 in for x, so then I do x squared, which is 25, then there's only one possible answer for y. And if any number I choose there, let's say if I put 3 here, so 3 squared, the only possible choice is 9. So this would be a function because every input would have only one possible output. So this one, the opposite. If I draw a table of values again and try it, let's say that I put in x is 4. So if x is 4, I have to think, what squared gets me to 4? Well, I know it's 2. So I think, oh, okay, it must be a function. Well, no, because if x is 4, you can also say negative 2 squared, because negative 2 times negative 2 is 4. So then this is one where it's not a function because x could be paired with 2, but it could also be paired with negative 2. So it would not be a function. And then on this one, if you try different things, you'll notice that this is not a function also. So I want you to understand why, but if you are looking to memorize something, the x can be squared, but if the y is squared, it is never a function. So on this one, the y is squared, so it won't work. And that's because of positive and negative numbers. And I do not want you to do this down here. I want to save that and bring it out of your memory tomorrow.